Hello everyone, welcome to Canal Physics. Today we are looking at order of magnitude and estimation. To start, we will recap some basic index laws that you will need to know. So in this table we've got A representing the base number, and this is usually 10, and the power is in the top right. So any number raised to the power of 0 is equal to 1. So here I've got the examples. 10 to the 0 is 1. When you multiply two numbers with the same base, to get the result, you add their powers. So you can see here 10 to the 4 times 10 to the 2 is 10 to the 6. If you're dividing, you subtract the powers. So 11 take 6 here is 10 to the 5. If you're raising a power to a power, then that's going to be multiplied. So you do here negative 3 times 3. So it's good we see a negative example there. Negative 3 times 3 is negative 9. And if you're finding the inverse or the reciprocal of a base to a power, that power becomes opposite sign. So 1 over 10 to the 8 is 10 to the negative 8. Now if I had 1 over 10 to the negative 8 here, then that would become 10 to the positive 8. Before we can understand order of magnitude, we need to know that any number can be written in index form with 10 as the base. So for example, 1000 can be written as 10 to the power of 3. 7.7 can be written as 10 to the power of 0.886, and that is an irrational number or an irrational power. And 0.031 can be written as 10 to the power of negative 1.50, and also an irrational number. So how did I know these powers? Well, there is a button in your calculator which is log. It is written like log. So this is short for logarithm. And to find the power that a number can be expressed as with the base 10, you simply take the log of that number. So the log of 1000 is equal to 3. The log of 7.7 is 0.886, etc., etc. And the log of 0.031 is equal to negative 1.50, etc., etc. Now we're ready to understand order of magnitude. And this is simply the nearest integer or whole number power of 10 for a certain number. So the first example is easy because that's already an integer. So the order of magnitude, which I'll put in square brackets, OM, is 3. But for the next example down, you simply round to the nearest whole number, and that's 1. So the order of magnitude for 7.7 is 1. And for the final example, the nearest integer is negative 2. So our order of magnitude is negative 2. So we know from rounding that if the next digit is 5 or more, we round up, but if it's less than 5, we round down. So why does this say that 3.16 is the rounding cutoff for deciding the order of magnitude of a number? If we enter 10 to the power of 0.5 in our calculator, we get 3.16227, etc., etc., a rational number. But because values in physics problems are usually provided to three significant figures, we will round this to 3.16, and that's why we say the cutoff is 3.16. Examples always make things easy to understand, so let's try one. Let's consider a number in scientific notation, 3.40 times 10 to the power of 3. To decide the order of magnitude of this number, we first look at the coefficient, which is slightly above 3.16, that cutoff. So we can safely guess that the power will be slightly more than 0.5, which means when we rewrite this as a power of 10, we can round that up to 1, because it would be slightly more than 0.5. And don't forget the other part of the number, 10 to the 3. And using index laws, this will be 10 to the 4. Therefore, the order of magnitude is 4. Let's do another example, 3.09 times 10 to the power of negative 7. Again, rewriting 3.09 as a power of 10. That's slightly below 3.16. So we are going to round down 10 to the power of 0, because the power for 3.09 must be slightly less than 0.5. So we will go down to 0. and not forgetting the 10 to the negative 7. Adding these two powers gives us 10 to the power of negative 7, and therefore order of magnitude for this number, 3.09 10 to the negative 7, is negative 7. And let's do one more example using the cutoff. So 3.16 times 10 to the power of negative 2. So because 3.16 will be written as 10 to the power of 0.5, okay, we will round 10 to the power of 0.5 to 10 to the 1, and that will give us 10 to the power of, so 1 plus negative 2, that will be negative 1. Therefore, the order of magnitude for this number is negative 1. Estimations and approximations are useful when specific measurements are not necessary. For example, knowing that it takes about 20 minutes to drive to the shops from my house is good enough to plan my day. Knowing the extra seconds and microseconds doesn't add any meaningful information for me. Or knowing that the sun is about 8 light minutes away from Earth, which means it takes sunlight 8 minutes to reach Earth from the sun, that gives us a good idea of how far away the sun is. So applying this idea to this example, we're asked to estimate the combined mass of all humans as an order of magnitude in kilograms. So at the time this video is made, the population of humans, I'm going to use capital P here to represent this, is 8 billion people. Now, a billion is 9 zeros, so I'll write that out tediously, but we can more conveniently write this in scientific notation. And to get closer to the answer, we need to rewrite 8 as a power of 10. So just a little side working here, we'll get the log of 8, and our calculator tells us this is 0.903, etc., etc. So therefore, 8 can be written as 10 to the power of 0.903, etc., etc. Therefore, this approximates to 10 to the 1. So I can rewrite the population as 10 to the 1 times 10 to the 9. So my estimate of the human population, 8 billion, can be rewritten as just an order of magnitude. And that is 10 to the 10, because 1 plus 9 is 10. So now that we have an approximation for the total number of people, we need to make a reasonable estimate for the mass of a human. And this will obviously have a range of acceptable answers, but I'm going to go with around 60 kilograms. So now we need to rewrite 60 as a power of 10, because we're asked to get the order of magnitude as the final answer. So again, a little side note here, the log of 60, this gives us 1.778, etc., etc. So 60 can be rewritten as 10 to the power of 1.778, etc., etc. So I can approximate the mass of a human, my estimate of the mass of a human, to 10 to the power of 2 kilograms. So to find the total mass, I'm going to write M subscript capital T for total. That would be the mass, my estimate for the mass of a human, times the population, and this will give me the total mass. This is going to equal 10 to the power of 2 kilograms multiplied by 10 to the power of 10, and 2 plus 10, I'm going to get 10 to the power of 12 kilograms. So this is the approximation for the total mass of humans, and this is an order of magnitude of 12. And that's it. Now for the next example, approximate the circumference of the Earth as an order of magnitude in SI units. The diameter of the Earth is approximately 13,000 kilometers. The formula for the circumference of a circle is 2 pi r, and this is going to be an approximate for a couple of reasons. One, we're given an approximate value of the diameter of the Earth, and we're also assuming that the Earth is a perfect circle. So the only value we're given is the diameter. So let's just do a little side working here. So diameter equals 13,000 kilometers. In scientific notation, that's 1.3 times 10 to the 4 kilometers. Now the radius is half of this, 6.5 times 10 to the power of 3 kilometers. But since we're asked for SI units, we need to convert this to meters. And that's pretty simple. With scientific notation, we just have to add 3 to this power. So there we have it. But because we're asked for order of magnitude as well, we need to rewrite 6.5 as an order of magnitude. And since it's above the 3.16 cutoff, we can write 10 to the power of 1, not 0, times 10 to the 6. And we have 10 to the power of 7 meters. We're going to have to do another little side note here. We need to express 2 and pi as a power of 10 as well. So we'll start with 2. So 2 is, again, below the 3.16 cutoff. So we can approximate that to 10 to the power of 0. Now pi, that is equal to 3.14, etc., a rational number. And that's, again, just below the 3.16 cutoff. So that approximates also to 10 to the power of 0. So now we can put all of these powers of 10, 2, pi, and radius into our circumference formula. So substituting gives us this. And using index laws, we have 10 to the power of 7 meters. So the order of magnitude is equal to 7. That's it. Thank you for watching this video. If you found it helpful, please like and share it, and subscribe to my channel for more.